All right, let's go ahead and get started. We want to take a look in this worksheet at the relationship between the mole and mass. So remember that on our last worksheet, we were looking at the relationship between moles and particles. And we said that there were 6.022 times 10 to the 23rd particles, whether they be atoms or ions or formula units, in 1 mole. But how much do they weigh? Well, let's take a look, for example, at helium. In this first question, we're being asked, what is the average mass of a single helium atom? So remember that a single helium atom is going to be obviously very, very small. In fact, so small that grams does not begin uh, to represent the magnitude of how small an atom is. So we're going to be using something called the atomic mass unit. So an atomic mass unit then is the size or the scale that we use to measure small, very, very small things like atoms, formula units, and ions. So there are 4.00 atomic mass units of mass in one atom. If I were to hold one atom of helium in my hand, it would have this mass, 4.00 atomic mass units. I got that number, by the way, by looking at the upper right-hand corner of the periodic table. If you want to go to 3 numbers after the decimal, it would be 4.003, but 4.00 is just fine for us for now. Now, if I had 1 mole, if I had 6.022 times 10 to the 23rd atoms of helium, the magnitude would be the same, 4.00, but the unit would be different. It would be grams. So one more time, if I have 1 atom of helium, it would have a mass of 4.00 AMU. But if I had a mole of atoms, it would be 4.00 grams. All right? So that'll get us started. Let's look at number 2. It says if a balloon contains 0.400 grams of helium, how many moles of helium are in it? Well, let's start with what we know. So I like to circle what they've given me, and then I'll underline what I'm being asked for. I'm being asked for the number of moles of helium. So I'll underline moles of helium. And then what I'm going to do is write what I've circled and put it over 1. So I've got 0.400 grams of helium. I'll put that over 1 times whatever unit is in the upper left-hand corner is going to go in the lower right-hand corner. So grams of helium is here, so we put grams of helium here. Whatever unit I'm looking for goes in the upper right-hand corner. Note that moles of helium is underlined, so that's what I'm looking for. So I'll ask myself the question, how many grams does 1 mole of helium weigh? Well, we've already answered that in the previous question. It's 4.00 grams of helium. So now what I'm going to do is cancel units. Grams of helium goes away, and I'm left with moles of helium. Now what I'm going to do is I'm going to divide 0.400 by 4.00, and I get this number, 0.100 moles of helium. Notice on the 0.400 there are 3 significant digits. On this number, 4.00, there are 3 significant digits. So I want to have 3 significant digits in my solution. 0 is a leading, this 0 here is a leading 0, and so leading zeros are never significant. I've got 1, 2, 3 significant digits in my answer, so I'm satisfied with that answer. Let's take a look at number 3. It says a diamond contains 0.90 moles of carbon. That's what I've been given, so I'll circle it. What is the mass of the diamond? So I'm looking for the mass of the diamond. By circling and underlining, I know exactly where to start and where to end. I'm going to start with 0.90 moles of carbon. I'll put that right here, 0.90 moles of carbon. Put it over 1, and then whatever unit's in the upper left-hand corner goes in the lower right-hand corner. Whatever I'm looking for, grams of carbon in this case, because it says mass of the diamond, grams of carbon in the upper right-hand corner. Now what I'm going to do is I'm going to cancel this unit with this unit. That's going to leave me with grams of carbon. I have 0.090 times 12.01. If I do that on the calculator, I'm going to get 1.1 grams of carbon. Notice I can have only 2 significant digits. Leading zeros never count, so it would be 1.1 grams of carbon for number 3. Let's look at number 4. How many moles of silver are in a ring that contains 3.5 grams of silver? Circle what I've been given, underline what I'm looking for. I'm looking for moles of silver this time. What I've circled tells me where to start. What I've underlined tells me where to end. So I've got 3.5 grams of silver. I'll put that number over 1. Whatever unit's in the upper left-hand corner goes in the lower right-hand corner. We've got grams of silver there. Moles of silver on top, because that's what I'm looking for. How do you know? That's what's underlined. Now this unit and this unit will cancel, leaving with me with moles of silver. Now notice these two numbers are one on top and one on bottom, so I'll divide this time. 3.50 divided by 107.87 will give me 0.0324 moles of silver. That should be your answer. Notice again, 3 significant digits here, 5 significant digits here. I'll need 3 significant digits in my answers. The leading zeros don't count. Let's look at number 5 now. It says a vitamin contains 1.5 times 10 to the minus 2 grams of zinc. Let me circle that because that's the number that I've been given. How many moles of zinc are in the vitamin? So I'm going to take what I know, the 1.5 times 10 to the minus 2, and put it over 1, just like that. Whatever unit is in the upper left-hand corner goes in the lower right-hand corner. They'll cancel just like that, leaving me with what I'm looking for, moles of zinc in the upper right-hand corner. Now I've got a number on top and a number on bottom. I'm going to divide because one's on top and one's on bottom. If one's on top and one's on bottom, I divide. If they're both on top, I multiply. I'll divide this time. And when I do, I get 2.3 times 10 to the negative 4. Make sure you know how to put these numbers into the calculator. The 1.5 times 10 to the minus 2. For example, for scientific notation, make sure that you know how to put that into the calculator. So we get 2.3 times 10 to the minus 4 moles of zinc as our answer. Number 6. A nail contains 0.10 moles of iron. How many grams of iron are in the bale? Start with what we know. I'll circle that, and I'll underline grams of iron just like that. So this is what we started with, 0.10 moles of iron. Put that over 1. Whatever unit's in the upper left-hand corner goes in the lower right-hand corner. Notice these two are going to cancel. These two units are going to cancel. And what I'm looking for is grams of iron that goes on top. So we have 0.10 moles of iron over 1 times, I've gotten this directly off the periodic table, 55.85 grams of iron per mole. So now I'm going to multiply these two numbers to get my final answer. Remember, I want, I'm going to need two significant digits here. Let me change this answer to 5.6 grams of iron because I only have 2 significant digits here. That should be 5.6 grams of iron right there. All right, let's go to number 7 now. Number 7 says an aluminum can has a mass of 10.8 grams. Let's circle that. And how many moles of aluminum are there? So I'm going to start with what I know, 10.8 grams of aluminum over 1. Whatever unit's in the upper left-hand corner goes into the lower right-hand corner. I'm looking for moles of aluminum. That's what's underlined. So moles of aluminum in the upper right-hand corner. These two units will cancel. 10.8 divided by 26.98 gives me 0.400 moles of aluminum. That's what's left in the upper part. So 0.400 moles of aluminum is my final answer. Let's look at number 8. Number 8 says a piece of copper had a mass of 3.4 grams before a reaction and 1.79 after the reaction. How many moles of copper reacted? Well, if we started with 3.4 grams and we ended up with 1.79, then that must mean that the difference, 1.61 grams, must have been what reacted. So we'll start with the 1.61 grams of copper. So 1.61 grams of copper over 1, whatever unit's on the upper left. By the way, this is what I'm going to start with, and I'm looking for how many moles. I'll underline moles right there. So 1.61 grams over 1 times 1 mole per 63.55 grams of copper. You can get that right off the periodic table. So grams of copper cancel away. I'm going to divide these two numbers and I get 0.0253 moles of copper, and that's my final answer. And final question, number 9. It says a lead fishing weight has a mass of 18.7 grams. How many moles of lead are in the fishing weight? So I'll circle what I know. What I've been given is the 18.7 grams. I'm looking for moles of lead. So 18.7 grams of lead over 1. Grams of lead is on upper left, so grams of lead, that unit goes in the lower right. And what I'm looking for, moles of lead, on the upper left is grams of lead, lower right, grams of lead, upper right, moles of lead. So notice that these two will cancel, and I'll be left with moles of lead. From the periodic table, 207.2 grams of lead is what 1 mole of lead atoms weighs. And so I'll divide these two, and when I do that, I get 0.0903 moles of lead, and that will do it for us. Folks, I'll see you on the next one. Thank you. Bye-bye.